What if you could answer complex questions by combining math calculations with real-time web searches in just a few lines? You'll see how to create a DSPy agent that uses two specific tools: a Python interpreter for executing math expressions and a Wikipedia search function for retrieving facts. The example will show this agent solving a question that requires both numerical computation and external knowledge lookup.
Def evaluate math expression, SDR float. Return DSPy Python interpreter, execute expression. Def search Wikipedia query, SDR. Results equals DSPy. Call BirdEv2. URL equals http://20,102.90.50.2017/wiki17 abstracts. Query k equals 3. Return xtext for x in results. React equals DSPy. React. Question answer. Float. Tools equals evaluate math. Search Wikipedia. Pred equals React. Question equals: what is 9,362,158 divided by the year of birth of David Gregory of Kinnerty Castle? Print pred answer.
This demonstrates tool-augmented program synthesis, where a language model solves a problem by composing external tools through a declarative interface. The code defines two specialized tools, one for executing Python math expressions, another for retrieving Wikipedia abstracts, and packages them into a single React module with a clean input-output signature. The key distinction is how the complex workflow, retrieval plus computation, is exposed as a simple function call. The pattern works by treating tools as first-class citizens in the reasoning pipeline. When invoked, the React module automatically determines which tools to call based on the question's requirements, executes them in sequence, and returns the final result. Here, the agent doesn't perform adaptive multi-step reasoning. It strictly follows the linear flow implied by the question. First, resolve the unknown birth year via search, then apply it to the math operation. This keeps the logic transparent and the tool interactions explicit. This approach matters when you need to combine deterministic operations, like math, with knowledge retrieval in a single, maintainable pipeline. The value is in the clean separation. Tools encapsulate domain logic, search, computation, while the React module handles orchestration. The trade-off is that the agent's behavior is entirely determined by the tools you provide. It won't invent steps beyond what's explicitly defined in the signature and toolset. Let's break it down line by line.
Def evaluate math expression, SDR float.
This defines a function named evaluateMath that accepts a string parameter expression. The return type annotation, float, indicates it's expected to return a floating point number.
Return DSPy Python interpreter, execute expression.
This instantiates a DSPy Python interpreter with empty configuration and immediately executes the provided expression string. The minimal setup with uses all default interpreter settings, while execute evaluates the string and returns the raw result.
Def search Wikipedia query, SDR.
This defines a Wikipedia search function that takes a string query and returns results. The type annotation SDR indicates it should return a string, though the actual implementation, shown later, returns a list. A mismatch this single line doesn't resolve. In the React system, this function will serve as a tool for retrieving external knowledge when the agent processes questions requiring factual lookup.
Results equals DSPy. Call BirdEv2. URL equals http://20,102.90.50.2017/wiki17 abstracts. Query k equals 3.
This calls a call BirdEv2 retriever at a specific Wikipedia abstracts endpoint, passing the user's query. The k equals 3 parameter limits the search to the top 3 matching results.
Return xtext for X in results.
This extracts the text content from each search result dictionary, returning a clean list of strings. The React system needs just the text snippets, so this filters out all other metadata from the call birdiev2 response.
React equals DSPy, react, question answer, float, tools equals evaluate math, search Wikipedia.
This initializes a React agent that combines reasoning with tool use, specifically wiring up our two defined tools: evaluate math for computation and search Wikipedia for context retrieval. The question answer, float, signature declares that this agent must return a numeric result, matching the mathematical nature of the example question.
Pred equals react, question equals, what is 9,362,158 divided by the year of birth of David Gregory of Kinnerty Castle?
This executes the React agent with a question that requires external data lookup. The agent will process the natural language query, determine it needs Wikipedia search to find the birth year, then perform the division calculation.
Print pred answer.
Outputs the computed answer from the React execution. This displays the result of the single question processed through the pipeline, combining math evaluation and Wikipedia search. DSPy React composition. This code creates a React agent that chains two concrete tools, evaluate math for executing Python expressions and search Wikipedia for fetching abstracts, then applies them to decompose a single arithmetic question. The pred object captures the agent's final answer, while React encapsulates the tool selection and invocation logic in one signature. Tool outputs feed directly into the LM's reasoning without preprocessing, making output quality dependent on raw tool responses.
The query that finds nothing carries all answers.